Welcome to my first Q&A video. I figure I'll do one of these once a month. That way, even if someone didn't watch every single video or read the comments, they could learn something and maybe have one of their questions answered in the process, or get some insight into something they didn't think of. I'll also be recording my very first Patreon video soon. Thank you to my first Patreon subscribers, Jorgen Carson. The support is very much appreciated. And thank you also to everyone who gave me one-time subscriptions or bought products through the affiliate links or bought copies of my albums through the links. All that support helps and I appreciate it. So what I'm going to do is walk through the videos that I've posted in the last month or so, and then mention questions that were asked by particular users that I think will be useful to the community, and give you a quickie answer. Now, I did answer most of these in the videos themselves, so I'll reference the video before I do each of the questions. That way, if you want a little bit more information, you could just go dig in the comments for it. And if there's something you're interested in that I didn't touch on, you can go ahead and ask in the comments of the videos. Or if there's a subject that you want me to cover, go ahead and post that in the channel comments, and I'll see about getting to those. No guarantees, but if it's something I can do easily, why not? Also, the way I'm configuring Patreon subscriptions is supporters of my Patreon and supporters at different levels get priority as far as the questions that they ask and the type of subjects that they would like me to cover. They also get access to more of the in-depth inner workings of the channel, as well as some design files. Now, I'm just getting this started, so a lot of that isn't posted yet. I'm trying. It's a holiday around here, and things have been a little bit crazy. Plus, I'm just getting this off the ground. So stick around, and in the coming months, I'll be posting more and more content there. Anyway, on to the questions. First two questions are from my Ramps series 1 of 4. That's the board comparisons. Mod Mike asks, I took a chance on a Ramps board, and it's a piece of expletive deleted. The Robotal board is available locally for cheap. I understand the microstepper jumpers are bridged, but can't you just cut the traces and install jumpers again to regain functionality? Does it even make a difference if I plan to go SPI and control from Marlin, and 32-bit or not? Also, I was wondering if you'd explain the difference between the Ramps 1.5 and 1.6 that I see on Amazon. Thanks for the questions, Mike, and let me see if I can get to those. As far as the boards like the Robotal and the Key Station, what he's referring to is that with the Ramps boards that are labeled Ramps 1.4a, the jumpers are bridged with on the PC board. So no matter if you have jumpers installed or not, they're always going to be on. And he was referring to the Trinamic drivers, which don't use necessarily the jumpers for configuration, because you could do that all in SPI with the TMC 2130s. Or over UART serial interface with the 2208s. So the only problem there is that, well, if you're using like the Allegro drivers or the Texas Instruments drivers or any similar driver, if you're using a mode where it's all three jumpers in, it doesn't matter. You just can't change it to a lower resolution. Now with the Trinamic drivers, if you're using the SPI or the UART, it ignores those jumpers altogether, except for jumper number 3. Now, at least that one has to be scratched out, or should be scratched out. Otherwise, it puts 5 volts on a logic pin input, and I think it's, or a diag input, and I think that's supposed to be... Sorry, there's a cop car going by. Otherwise, it puts 5 voltage in on a diag out pin. I don't know what effect that would have exactly, but it's meant to be open. The good thing about those boards is it's the top trace, which is a thinner trace, and it's more accessible if you want to scratch that out. So all you have to do is take a little pair of needle nose pliers and work the plastic jumper off, and then scratch out the very thin trace between the 2 pins, or all 3 of them. Now, 32-bit board or not, that really depends. 32-bit boards offer a lot of nice features. Some of the firmwares are pretty nice, like SmoothieWare and RepRap firmware. I like that you can keep the config files just on a text file and dump it on an SD card and stick it in. It's nicer than having to flash it every time. Plus, the clock speed is a lot higher, and it can handle floating point operations. The problem I have with it is they're still really expensive. So if you can splash out for a 32-bit board, go ahead and do that and support the development. If you're on a tight budget and you're just worried that you won't be able to get the same quality out of an 8-bit board, you can get most of the way there with some tricky settings. You're just not going to have things like dual SD card support, color touchscreens, and those sorts of things. Sending out stepper pulses that are sufficiently fast is going to depend on the topography of your particular printer or the kinematics platform. because you can run out of headroom real fast, especially on like a Core XY or a Delta printer. But if you go back and watch those videos, you can see that I actually run tests at quarter stepping with interpolation, and it's still pretty smooth and pretty quiet. So you're not completely sunk there. And even if you buy one of these boards and try that out and you don't like it, you're only out the cost of a ramps board, which is a couple bucks, as opposed to the 32-bit boards, which are over $100 usually. Also with the ramps boards, there is the option to buy a rearm board, which is a 32-bit that fits in the Arduino Mego format, and just plug that into the bottom of your ramps. And version 2.0 of Marlin is actually using that rearm as the basis for a lot of their testing. So by the time that comes out, it should be fully supported. Hopefully, fingers crossed. And those are about 40 bucks, plus the price of your ramps, so that's not bad at all. And also, I was wondering if you could explain the difference between the ramps 1.5 and 1.6 that I see on Amazon. I actually have a 1.6 here for testing, I just haven't gotten around to it yet. The 1.5 I did include in the ramps comparison, so series 1 of 5, the ramps comparison, you can see what I thought about that one. I'll show you this that I have right here attached to my torque setup. The big difference between this and a 1.4 is that it uses the surface mount MOSFETs, which use the board for heat sinking. Now with the 1.5, those MOSFETs are the standard, what are they? The 55 NF05 MOSFETs, but those have a pretty high RDS on. It should be okay in these, as long as you're not, you know, super wacky with your bed. Also, with the standard ramps, you see it has the big thermofuses here. They used onboard fuses. Right there, they're really tiny. You can't really see them. Which is, I guess, good and bad. I will be doing the next installment of the ramps series is going to be concerning these poly fuses and standard, like automotive fuses and those types of things. So there will be more information about that there. But if something goes bad with these, and you have to replace them, you're going to have to solder surface mount components, and that's not the best thing in the world. As far as the 1.6, I'll open that up right now. The reason I wanted to try this one is because they upgraded the bed MOSFET, so it has a much lower RDS on, and it should technically be able to handle just about anything you would want in this type of a form factor. Unless what you want is like 800 watts, which is insane. It also has this rather large heatsink that goes across all three of the MOSFETs, which is very nice. Furthermore, they upgraded this connector, which is the output for the bed, so that should be able to handle much more current. The one downside I see is there's only one power in connector, and you can't disconnect it. I like that feature with the little plug on the ramps board. It makes things more portable if I have to move it around the workshop, or if I have to test different voltage power supplies and that type of thing. But if you're going to run your bed and your steppers at the same voltage, that should be fine. Another downside, though, is that all the current for the bed and your steppers is going into that one connector, and I have not tested these connectors yet, so I don't know how much power they can take. Again, hopefully I can get to that video soon. I have a ton of videos on the plate that are coming up. On that same video, Doug C. says, in regard to my telling people to heat sink the MOSFETs on the ramps boards, one very fatal flaw in all the ramps is if the heatsink of, let's say, D8 touches the heatsink of D9, your software will not have the ability to control the MOSFETs. Your 3D printer will show the heat bed getting hotter and hotter. You can click kill the heat bed temperature in the software, but the touching heatsinks switch on the D8 MOSFET. Now, I don't know what would happen if this happened when someone wasn't aware or wasn't home. Thanks for the question, Doug. That's a good point. Let me fill in on real quick. So the MOSFETs have 3 feet and a tab. Now your tab is actually attached to one of those feet, usually the middle. So if you were to short circuit the one tab to the other tab, you would have whatever's voltage is coming into here and whatever voltage is coming into here on both of those drains, and you would effectively just be paralleling these MOSFETs and then splitting the feet out into their respective circuits. Now the problem with that is that if you're trying to regulate one or the other of these, you'll get wonky results. So if you were to put a heatsink on one of these MOSFETs, whatever voltage this tab is on is going to be on the heatsink, and obviously you don't want that to short out against other components. So if you're not confident that they won't touch, you can either use one of these thermal resistance pads or thermal isolation pads that goes on the block between the heatsink and the MOSFET, as well as an isolated screw. Or you can use an isolated MOSFET package, which doesn't dissipate as much heat, so that's not great. And also, the little 3mm mounting bolts have these shoulder washers that fit in here and make sure that you don't conduct electricity through the bolt itself. And these isolators, they also come in things like mica, like rigid isolators and that type of thing. And you can smear heatsink compound on both sides of those and improve the way that it works a little bit as far as its thermal characteristics. And more importantly, if you're doing high voltage experiments, it'll keep you from, electrocuting yourself. But we're pretty safe at the voltage that we use 3D printers at. On to ramps series 2 of 5. Now this was my MOSFETs, what do they do and why they blow up video. Peter Oak says, I reverse engineered a couple of external MOSFETs boards and found them to have a divider network to prevent having a full 24 volts applied to the gate. It worked out that one applies about 12 volts and the other about 10. Both are perfectly acceptable. Now, what he's referring to is I warned in the video that some of the external MOSFET bed boards use a circuit that runs the voltage past the gate, and it uses an opto-isolator, and you get the entirety of the high voltage on your gate, which is not great if the gate voltage is, like it usually is in MOSFETs in this range, about 25 volts, because that only leaves you 1 volt of headroom, and you really don't have any margin of error on the gate voltage of MOSFETs. I mean, you can blow them out if they don't have some kind of internal diode protection. You can blow them out just shuffling static electricity across the floor and touching them wrong. So I didn't go into things that you could do with that, like using a Zener diode to limit the voltage or a regulator or anything like that. But what he's saying is they used just a simple voltage divider to make sure that you never get the full voltage on your gate. And that would mean you would be able to use up to about like 48 volts and you would still, the MOSFET will be fine. So that's good. If you're looking to use an external MOSFET for your bed because you didn't want to mess around with replacing the MOSFETs on your ramps board, check and make sure that those boards have either a voltage divider or a higher gate rating so that you don't blow your MOSFET out. Mod Mike asks, how do you feel about AC heat beds? They are quick and they take the load off the board. My only issue is that they operate in bang bang mode. Is that a problem? Is PWM and PID mode really an advantage? Thanks again, Mike. Now, what he's asking is about the AC heated silicone beds. Now, those are really the only option if you want to do a super large bed or a super high wattage bed. Because if you look at Ohm's law, when you have very high voltage and you're trying to pump out that wattage, you're using much less current than if you used a very low voltage trying to pump out that wattage. And those beds work in bang bang mode, which means they're just, on to get it hotter, on to get it hotter. They don't have closed loop PID control, which is just, the separate P, I, and D parameters and pulse wave modulation to control the current of the bed. You get much tighter control with PWM. The biggest concern I have about the silicone pads is that since they are running at AC voltage, whatever's coming out of your wall, be it like 120 volts in the US or 240 abroad, if you have some kind of short from the heating element to the metal frame of your printer, you're going to have all of that voltage on your printer, which is dangerous, obviously. Furthermore, the leads or the wires that go from the bed, where you're going to be taking a lot of the strain from motion, same thing with those. So you could end up with high voltage potential on your bed. Plus, bang bang mode can give you uneven layers on the Z-axis, but it's not really as bad if you have a nice thick aluminum bed that you're using, and you probably would in that type of a printer because you're not going to be putting it on a moving bed printer. You'd be using it on a large platform that's going to be moving on lead screws or whatever in the Z direction. Next video is a 5-minute data dump. It's a TMC 2130 and ramps with LCD and SD reader. W Barber 69. Originally I thought that was Warbear 69, which is cool, but W Barber's fine too. The latest bug fixed branch of Marlin he's talking about adds support for software serial for TMC drivers, no more using aux 3. Now I'm using servo pins for the cable select and aux 2 for the software SPI. Very true. I answered that in the comments, and I did actually use that bug fix branch for the demonstration video, but since that feature hadn't made its way into main branch yet, I didn't include that. So I'll make an amended video once that rolls into main and is stable and bug-free. I do use the software SPI option for the TMC 2208 video, as you can see in the setup part of that, and it does work very well for that. So I may or may not in the future, when I'm using TMC 2130s, use the software SPI option. It depends how many pins I would have to lose doing that. For me, the option is still, the easiest option is still just running a cable out from underneath the ramps board from the programming port. Like that. Let me see if I can pull this board off of here real quick. So you can see for this example, I just ran some jumpers off the programming port, put a little hot glue on there to make sure that they weren't going off anything, and that'll go to all of the TMC 2130 drivers. That way all of my auxes were free to do whatever I wanted with them. David N. Gein asks, you mentioned there are, quote, a few novel ways that you can kill these, end quote, and therefore you should use a protector. Care to elaborate? What he's referring to is in the Trinamics video, I used the diode protector boards that Vatarat sells. In the Trinamic data, it says that if you leave the logic voltage running on the board when you disconnect the mains voltage or the high voltage to the drivers, you can blow them out. Now, I haven't blown out one that way, and I have accidentally done that a few times, but other people online didn't know that, and the very first time they turned out their high voltage so they wouldn't have to listen to their fans and stuff so that they could flash their firmware, they blew out their Trinamic boards. This really only affects you if you're running your ramps and your Arduino off different voltage or off different power supplies. For example, if you cut the D1 diode that feeds power through the Arduino's regulator to your LCD and your drivers and that type of thing, and then running your ramps board at 24 volts or 36 or 48 volts or whatever you're running it at. So what I do there is I always power my Arduino off of USB, even if it's not plugged into the computer, and I have that powered from a USB powered hub, just a little, well, I can't pull it because it's taped down to my desk, but just a little cheapy. I hook that up to a power strip, the same power strip that I have the high voltage plugged into. I have them both always on, and then I just use the power strip to turn them on and off so that they turn off and on at roughly the same time. Plus I have the diode protector board, so hopefully that'll be a magic talisman against any kind of fryage. And like I said, I haven't popped one of those since, so it should be okay. From the video, high-speed real-time print, where I print a tree frog at ridiculous speeds. Jeff Frylet asks, how did you turn two Xbox PSUs into a 24-volt PSU? As long as you have two switch mode power supplies that have isolated outputs and they are roughly, or I guess as close to exactly the same as possible, I should say, you can run them either in series or parallel with each other. So if you have the, let's say typically if you had one power supply, you would have your negative and your positive. Your positive is hooked up to your voltage plus and your negative would be grounded. Well, if this is floating, then your negative reference, it doesn't care if it's a ground voltage or 100 volts or whatever. So you could take that to two power supplies. If it's 12 volts and 12 volts, your potential is 0, 12, 0, 12. And then if you tie 12 to your 0, then this reference becomes 12 and this becomes 24. So you would just ground this and then hook this up to your high voltage supply. Now, to protect your outputs, you should run two anti-parallel diodes, one across each output, just in case they don't turn on and off at the same exact time. And then obviously don't power each of those on with the switches on them if they have switches. The Xbox supplies don't. I have those hooked up to a power strip, and then I just use the power strip to turn it on and off. And that's what I'm using on my test bed printer. I have been for months through hundreds of prints, and it works fine. Now, Xbox supplies are obviously more expensive than just buying one of the LED supplies that people usually use for these, but I can get these at a thrift store for a couple bucks a piece, so I just have 7 or 8 Xbox supplies lying around for these types of projects. And when I pulled them apart, they were made by Delta, and I was able to go to Delta's website, and I couldn't pull down the exact Xbox power supply data sheets or anything like that, but I was able to pull down the data sheets and schematics for what the Xbox supplies were based off of, which was some sort of medical supply that they also use for laser printers or something like that. I don't remember. and some kind of isolated network supply. Also on that video, DSE Tomahawk asks, so would you recommend using the TMC 2130s at quarter step setting in general, or would I be fine running them with all jumpers on in the ramps 1.6? Again, to get around the low clock speed of the Arduino Megas, I'm running those drivers at quarter stepping, so that'll give me a lot more computational headroom. And then depending on Trinamic's software interpolation to smooth out the movements and keep the noise down. And as you can see from that video and the torque test videos, it works pretty well. You actually get a little bit more torque across the board with that one general setting, and it's not all that much louder and less smooth. And it lets me print up to about 240 millimeters a second without getting out of single stepping, like without going into the the burst stepping, double stepping and quad stepping. So in general, would I recommend it? Not really necessary to do if you have the computational headroom. I'm using a 2-to-1 reduction on that printer, which is why I had to buy myself more clock cycles. But if you want to print faster and your kinematics platform is designed and built well enough that it'll do that, and your extruder can handle the extra throughput, but you're running into computational headroom, there's no problem with going to quarter stepping. It doesn't look like. I haven't had an issue. The only weirdness is when you're printing at very low speeds, the software interpolation doesn't quite kick on, so it can be a little bit rough in terms of noise. But quarter stepping's enough that it won't stall out at those low speeds like it would with single stepping. And I haven't tested the exact torque curves with the 2130s and quarter stepping and all that stuff like I did the 2208s. And the 2208s are the second generation of these silent step sticks. So they all use Stealth Chop 2, which uses a stage of pre-regulation before you get to the regular brute force regulation. So you get a little bit more smoothness and torque overall with the 2208s than you do with the 2130s. So your mileage may vary, I should say. But again, it was the 2130s that I was running in that video for that high-speed tree frog print with a very simple, XYZ cantilevered Cartesian type of a kinematics platform. From the Trinamic Silent Step Stick Torque Curve Testing and TMC 2208 How-To video, Mod Mike says, I just ordered these, and again, I was wondering if you like these better than the 2130s you just reviewed. A comparison maybe ideal settings for the typical 3D printer users would be great. I'm going to be doing that. I want to do torque curve testing for not only the 2208s and the 2130s, but also the 2100s in, dummy mode and stupid mode, as well as other common drivers like the Allegro chips and the Texas Instrument DRV 8825s, just to see how they all stack up against each other. I also want to take noise readings with a SPL meter and all that kind of jazz. The reason I haven't gotten to that yet is because the initial batteries of tests that I did just for the 2208s took 8 hours, because industry standard is you test each torque point 3 times just to make sure there's no outlier. And I have to rewire the things, reflash the firmware, and switch the power supplies to do the different curves at the different settings. So just having to do that over hundreds of tests took literally an entire day, like just to run the test points. Then I actually had to crank the data, put it into a data sheet, generate line graphs, normalize them, and all that stuff. So I will get to it. It's just something that I need like a block of time, like an entire weekend to do. And with the holidays that just passed and the holidays that are coming up, that's just not something that has happened. So it will, though, because I am morbidly curious about how they stack up against each other. And I think that's an ideal subject for this channel, where we answer those really nerdy questions instead of just tossing a stepper and saying like, mine doesn't skip at this fast, which doesn't really give us any information at all. Jacob Sokolov asks, how are the jumpers configured? Whenever you're using one of the Trinamics that has the UART or the SPI interface, the jumpers don't matter, so they could be plugged in or they could not be plugged in unless you're running them in legacy mode. Then you'll have to refer to the data sheets to see which jumpers you're going to need. You also may have to modify your board because each of the jumpers has 3 states. It's either open, it's grounded, or it's tied to the VCC. And that's just not how ramps and some other different boards happen to be configured. They usually only have 2 states, and you have to pick one. But like I mentioned earlier, that MS3, the third jumper, that has to be open, or it's supposed to be open according to the data, because that's technically a diag pin out, and you don't want it tied to voltage plus or ground. You want that floating. From the Talk Nerdy to Me video, Intro to Stepper Torque and Inductance for 3D Printers. Philip Skorik asks, would like to read about the needed calculations. Any links? I really want to understand why. Also, could you post the link to the spreadsheet, Google Docs maybe? Now, he's referring to the video. I have a couple different videos. I have long-form videos, short-form videos, the Talk Nerdy to Me, where that's a warning, like this is going to contain a lot of math, and the 5-minute data dumps, where I try to take all of my blathering out and just have the nuggets of information that you need for the subject. So this was a Talk Nerdy to Me video, and there were a whole lot of equations used. As far as links, the best place to look would be control board and driver manufacturers, like not for 3D printers necessarily. They tend to not post any math, but for CNC machines or like precision robotics, somebody like Gecko Drives, they had a bunch of information. There were a couple extruder companies that had some of that info there. Also, the reprep.org forums and the wiki has that information as well. Now, as you know from the video, there are different rules of thumb, so to speak, for different types of operation. And just like Philip asked, I did post a Google Docs link to the spreadsheet that I used. You can't edit it online, but you can go to the link, download it, and then use it as you will. That has the equation in it, but it's not, the equations aren't written down. It's the, like, you know, the square root of this cell plus that cell divided by that cell type thing. So I did post some citation reference data and those equations on my blog, and there's a link from that video under Philip's question to my blog, and I think I put it in the description. One or the other, I don't know. So if you're interested in the nerdy math behind that, and if you're interested in having that spreadsheet yourself, yeah, just look in the description of that video and go to my blog and grab it. And I'll be posting that on the Patreon as well. Now, under the ramp series 3 of 5, the green connectors, how to keep them from melting, John Deegan asks, question, I've read a lot of people remove the green connecting blocks to solder directly to the board. Also, removing and replacing the poly fuses with automotive blade fuses, which is a separate matter. Would bypassing connecting block be a viable alternative, or is there complications with this? So a couple questions there. He's referring to taking a ramps board and pulling the poly fuses off and replacing them with regular fuses, automotive fuses, or just using an inline fuse. And he's also asking about the green connector blocks that melt down if you don't put things into them right. If you could just desolder those from the board and solder the wires directly onto it. Now, yes, you could do both of those things. Like I said, installment 4 of 5 with the ramp series is going to be all about the poly fuses and regular fuses. So I'll answer the question much more thoroughly there. There are pluses and minuses to each. One of the obvious minuses of automotive fuses is you're out like $1.50 every time you pop a fuse, which can get expensive if you're debugging a board that keeps popping fuses. But as far as the green connectors, taking it out and soldering, that's fine. The only problems with that, one is that you can't easily just unplug the connector and move your printer around, or unplug the connector and try a different power supply. Also, the copper traces on a lot of these ramps board are pretty thin, and it's very easy to destroy them by desoldering. And I know that with experience. I took apart, I don't know, 10 ramps boards or something like that for one of the demonstrations, and some of them were pretty rugged, and others, the foil was so thin that it just flaked away practically. It seems like the only thing holding it in place was the solder mask, like they were just built like crap. And that's not great because you need the combined surface area of the traces on top and the bottom of the board for those big connectors. Otherwise, you're making it worse for yourself than you are replace it than you would be with just using the green plug, because you have half your current carrying capacity if you screw up one of those traces. So you're going to have to also make sure that it's soldered on the top and the bottom. Now, the better quality boards have plated through holes, or they use eyelets and press them in. It's tough to know which ones do and do not have those unless you take it apart. And as an example of what I'm talking about, here's a PCB, proto board, perf board, whatever you want to call it, from Radio Shack, and that has the on one side. On the other side, it doesn't. That's a one-sided board. The two-sided boards will have this on both sides, but nothing through the hole connecting them. Whereas something like this, which is a much higher quality board, the hole itself is an eyelet that's threaded through, plated, and then there's a solder pad on the top and the bottom. And that's one that you would not have any trouble desoldering and resoldering to. Something like this, if you heat up these pads too much, they just peel right off. So just bear that in mind before you go doing surgery on your power connectors. On the video, testing steel reinforced poly timing belt. I'm sorry I'm going to butcher this name, but I think it's Kamiya Bidong or something like that. How about the double belt system that you're using? Do you think that it's worth it with the standard GT2 belt? He's referring to the belt that the system that I'm using on my test bed printer here. As far as I know, I'm the first person to ever do this, but probably not. I can't think that anyone hasn't thought of it before. But rather than directly pulling the print head carriage back and forth, I have bearings on it, and then the belt is secured at both sides, so that you get this sort of S-curve where it goes around and then back, around to the other side, back, and it's secured here. And the stepper motors are below it, or the stepper motor and the idler pulley, and that controls the motion back and forth. Now, the benefit of that is, with a standard belt, you only have the stop and the start tension, you know, that kind of shock of the moment of inertia, taken up by one length of belt on the other side. When you loop over the top, you have two layers of belt that are taking that up. So belt stretch is much less of a problem. Belt shock is much less of a problem. Also, so if you're talking about ringing harmonics in the belts, where, you know, they become taut very quickly and they vibrate like a string and make the head move back and forth and ripple, you have two different harmonics. So rather than just the one that's reinforced largely, you have two smaller ones that are different frequencies, and that cuts down on the ripple as well. So would I recommend it? I would. I like it. I have to do more tests. I want to build it up larger. So if I were to do ringing tests, I think I would find that it's just down to the stiffness of the kinematic platform that the ringing was coming from, and I don't think any of it's from the belt. Also on that video, Cthulpis says, thanks for the video. Thank you for the cool username. Core XY test will be awesome. By the way, what did you mean at 347 about not using steel reinforced belts on small pulleys? What I was referring to is, this is a steel reinforced poly belt. It's very stiff. You can see inside there are a couple steel belts in there to reinforce that. It gives it a lot more strength than these standard belts, which are, you know, aramid fiberglass type things and neoprene. The problem with something like this is it doesn't like to bend, and when you force that bend around a small pulley, you're putting a lot of stress on those steel belts here, which are not nearly as flexible as a fiberglass. So those eventually, from going back and forth, they start to fray and they just shred themselves, and then your belt is toast. So the steel belts, they work much better on the larger pulleys. And last video, Fusion 360 modal vibration simulation of a guitar string. That's where I took Fusion 360, I modeled a guitar string and showed you how to add constraints and modal analysis and tension and that type of thing. Karsten Kraus asks, would Fusion be able to simulate how different rep parts and a moving mass, i.e. extruder, lead to gantry vibrations? If yes, why hasn't anyone done it? I imagine one could, for example, reduce the moment of steel plate used in a P3 steel frame, or optimize printed joints toward least vibrations. Karsten and I are on like a mind meld link here. That's exactly what I want to build up to with Fusion. The problem is they have static load testing, and they're just getting dynamic load testing off the ground. It's in beta. I do have that enabled on my machine, and I've been messing around with it a little bit. They're still hammering out the details though. So you can do things like you could do a modal analysis on it just to see where the flex points are and at what frequency they will be. But as far as like stress and deflection with respect to like a particular moment of inertia, I think that's a little bit into the future, but I will be messing around more with it very soon. And they also have an optimize feature where you can take the tests of a particular part and then it'll tell you, hey, you have this much extra crap that you don't need on here. You can reduce it to this amount of mass and shape and carve this away. And it'll give you a 3D model of it that you can then use to iterate your design and bring the mass down a little bit, which is always nice. So I'll be testing that as soon as they get the dynamic strain testing down. So thanks for all the questions. If you watched this far, bless your little heart. Much more videos coming up, including the last 2 in the ramp series, reviews of particular components, a Talk Nerdy to Me section on extrusion, and some cookies and reviews on various parts. Thanks for making the first month of this channel awesome. Like I said, we're still getting off the ground with subscribers and that kind of stuff, but honestly, I didn't expect even the response that I got to some of these videos. And make sure to leave comments on the channel's page if there's particular future information you want me to go over that you just haven't seen tested anywhere else, or haven't seen tested as nerdily as I test things anywhere else. Now, if you're watching for just 3D printing, or if you're watching for just coding, or if you're watching for like just the guitar stuff, don't worry, I don't put one of those genres on hold to do the others. I try to mix them up and go back and forth and jump back and forth among them. So you don't see a 3D printing video for like a week or 2, don't worry, there's going to be one coming. And you guitar guys that are like, I don't care how to program an Arduino, I just want to know how good mahogany is. Well, stick around, I'll be having those coming out too. But until the next video, get out there and make something awesome.